Done. Sir, last class we have done up to this one. Relations of Kc, sir.
Okay. Do you know what is the relationship between Kp and Kc?
No, sir, not Kp and Kc, sir. We have done that for one reaction. You will be given 1 Kp and you will be asked to find it out for other reactions. That reverse one, reverse and square, revise and divide that one.
That's okay. That's okay. That's okay. But that reaction quotient and this all things, what will be the direction of equilibrium? This all you study already.
So
Okay.
QC lesser than Kc means forward reaction. QC lesser than Kc and QC equal to Kc is equilibrium.
Okay. Okay. Now, see, today I am selecting one more topic here. Relationship between Kp and Kc. Kp and Kc. Relationship between Kp and Kc. This is what we have to understand, right? Kp and Kc. Now, Kp, if you talk about, this is also equilibrium constant. Equilibrium constant. But what it is this? What is? In term of partial pressure. In term of partial pressure. Partial pressure. Now, suppose we are having the A mole of A and B mole of B. This is reversible, giving C mole of C and D mole of D. So how can we write Kp? So we have to write like that. Partial pressure of product. What is the partial pressure of product? What are the product? PD, that is D and C. So I am writing PC, that is partial pressure of C, power C. And then it is the PD power D, that is bracket is a smaller bracket. Then it will be the PA power going to be A, and here is PB power going to be B. This is equation 1.
Kp for the gas, no? Where we cannot find another one.
Yeah, that is P is what? Partial pressure. That is why they all are get. Now, Kc. This is equilibrium constant. It is also equilibrium constant. Yes or no? Equilibrium constant. What is this one? In term of, can you tell me what? In term of molar concentration. Getting my point. Suppose the same equation is there. A mole of A, B mole of B. It is reversibly giving C mole of C plus D mole of D. So what we can write here? Kc is equal to product of molar concentration of product. This is what? Product of molar concentration of product. So that is, this is C. Molar concentration means square bracket. And D power D raised to power their coefficient. And here is A power going to be A and B power it is going to be B. This is equation 2. Now, what is the relationship between Kp and Kc? That we have to understand. Okay. So here you see, here I am writing from ideal gas equation. Do you know ideal gas equation? From ideal gas equation. Tell me.
PV equal to nRT.
PV equal to nRT. That is okay. P is equal to N by V RT. N by V. What is meaning of N by V?
So N by V.
N by B means number of mole per liter volume. This is what? Molarity, yes or no? Number of mole per liter. What is molarity means? Number of mole per liter volume. Yes or no? So that is molarity we are writing, that is active mass, or that is square bracket RT. This is square bracket means molar concentration. Square bracket means molar concentration. Molar concentration, or that is also called active mass. This is also called active mass, or you can say that is mole upon per liter, volume in liter. So if I will write PA, So what is going to be? ART. If I will write PB, so what will be there? Molar concentration of BRT. If I will write PC, so it is going to be CRT. If I will write PD, so it is going to be DRT. These all the values, whatever the values you are getting here, these value can be placed which equation? These all the values, suppose it is 3, and you can place this value in equation number this.
1.
Equation 1. So I am writing here from equation,
So previous like
1 and 3. Okay,
the
I
previous
didn't. Okay. Check.
done.
Done. Good. Now, what we are going to do from one end, okay, so KP is equal to what we can write? What we can write? C. We have to write C. It will be in square bracket. Then it will be RT. See the value, how it is there. PC. PC means CRT. So CRT, power. What the power we are going to give? Power will be C. Then here it will be D in the square bracket, RT, and power will be D. Are you getting this one?
Yes, sir.
This is the A. Here is the RT. Power is going to be A. Here is B. This is the RT. Power is going to be B. Now, you try to solve it out. How can you solve? See, the similar terms we are taking in the outside. C, and this we are taking D. And here what will be the, when you multiply the power get added. C plus D. What it will be there? A, I have taken outside A power A, B power B. Here is RT power, what it will be there? That is A plus B. Now, this is the KP value. What is the KC value, Sanoy? You see the equation, this, if suppose I will consider this one 4. So from 2 and 4, from 2 and 4. What is equation 2? Can you see? Equation C power C, D power D, A power A, B power B. So here, if this value is also there, what is there? C power C, D power D, A power A, B power B. So KP is equal to, it will be equal to what? Can you tell me?
KC into
KC into, this will
RT,
be
C into
RT. See, C plus D, this is 1 bracket. They are the coefficient of product, minus A plus B, coefficient of reactant. These are there. Now, what is the delta Ng, Sanoy? Number of gaseous product minus number of gaseous reactant. So this is what? CD is the product and AB is the reactant. So what we can write? Kp is equal to Kc RT power. What will be there? Delta Ng. Can you understand this?
Yes.
Yes or no?
So done.
Done. Okay, let us see the, I'm erasing this one. Question I'm giving you. Write the expression, between Kp and Kc for following equation. I am giving you the equation. What are the equation? Equation A is there. N2 gas plus 3H2 gas. It is reversible. It is going to give 2NH3 gas. This is the one. B. What will be there? H2 gas plus I2 gas, it is reversibly, it is giving 2HI gas. Now, you solve this one. Okay. Can you do the solution?
Mm,
Yes.
Yes, sir, I can do. Sir, do.
Okay, do it.
N2 plus 3H2.
Correct. Good. What is the delta Ng value that you need to calculate
So,
first?
one.
Hmm. But the answer is wrong. You are doing wrong.
Sir, number del Ng for the second equation would be?
But the first one itself is wrong, na? First one. What is their del Ng? How you are calculating? So Ngp minus Ngr. So Ngp is how much? 2 mole of this one minus 1 mole nitrogen, 3 mole hydrogen. That is going to be 4. So it is coming minus 2. What you put here? You are putting 1. It should be the minus 2. So here it is going minus 2. So that is if you are writing this one Kp is equal to Kc. This is RT power. What we can write? RT power 2. Or that is what you wrote. That is again, it is correct only. There is no problem at all. Kc RT power minus 2. This is also correct. Now the second one you have solved here, 2 minus 2, that is power going to be 0. 0, anything value power 0 is equal to what? Suppose 100 is there, power 0, its value is going to be 1. Or 1 lakh it is there, 1 lakh, whatever is there, power 0 means it is going to be 1. So what will be there? Power 0 here putting that value, that is not what that you wrote correctly. This is correct. Yes or no?
Yes.
Okay, very good. What I need to do, can I erase this all?
Yes.
Actually, I am sharing the one PDF to you. Telegram. 1 minute it will take. Oh, it is not opening here. The problem is now. Yeah. Telegram. T-E-L-E-G-R. Just wait a moment. It is getting open. I'm giving you one question. See it. Yeah, I got the question. Sometimes it is very difficult to share the question also. So what I am doing, I am sharing to you this question to your WhatsApp number. Okay.
Yes.
Try to solve it there. If it is getting download here, that is okay.
Sorry, sir. You send me in WhatsApp.
This is Sanoy new number.
Sir, you're sending the older one.
Wait. Yeah, see the both the number I have sent. Yeah. Now see the question here. Is it visible to you?
Yes.
Okay. So what the question, first of all, you read the question, then we will do the separately this question. Okay. Question they are saying at 700 Kelvin, the equilibrium constant Kp of the reaction is given how much? That is 1.8 into 10 power minus 3. It is kilopascal. What is the numerical value of mole per liter of Kc? They are asking Kc for the reaction at the same temperature. So Kp given, Kc they are asking. So what we can do here? Okay, what we can do here? If you see. So here is Kp they have given. How much the Kp they have given this value you see? The Kp value 1.8 into 10 power. Can you tell me how much is there? 1.8 into 10 power?
Sir, forgot.
10 power minus 3. This is the kilopascal. That is one thing. And the equation is 2SO3. It is going to SO2 plus O2. All are the gases. This is gas, and this is gas. Now, what relation we know? Kp is equal to what is Kc?
Sir, what we have
RT.
to find here?
What?
So what is the question? I mean, sir, what we have to find here?
Kc they are asking, na? This equation now, only this is the question. Kc they are asking. RT power delta Ng. This is there. Now, first one delta Ng. Can you calculate delta Ng? This is 3 minus 2. Going to be 1. So, Kp value they have given, Sanoy. How much given? 1.8 into 10 power minus 3 kilopascal they have given. Kc they are asking. R value you should know. R value is 8.31. This is the kilopascal. And then temperature they have said already in the question 700 Kelvin. So if you are calculating this one Kc, so how much? 1.8 into 10 power, it is going to be minus 3 divided by 8.31 into 700. No, you solve this one. If you are solving, let me see this one. With 20, this decimal will be out. And so here is 18 into 10 power minus 4 multiply by 831 into 7. This is there. If you are solving this one, how much it is coming? 0.03094 into 10 power minus 5. You can rearrange this one. 3.094 into 10 power minus 7. The unit will be mole per liter. Can you do this type of problem? Understood or not?
Yes.
Okay. So this is all about the chemical equilibrium. What we have to do, that is we have to go for the ionic equilibrium also. So next topic, what you said, that is the acid-base concept. Can we move for that one?
Yes, sir.
Now, acid-base concept. Acid-base concept. So earlier time we study in the 10th standard, very few concept we study for the acid bases. Now there are several concept are there for the acid base concept. Okay. What are their acid base concept? First concept is there, that is called Arrhenius. Arrhenius. Arrhenius acid base concept. This is the first one. Next one is there, we are having the Bronsted. Bronsted-Lowry acid base concept. Third one is Lewis acid base concept. One more is there, but that is not in your syllabus. That is hard and soft. Hard, soft, and soft acid base concept. Its full form is called HSAB. HSAB. Hard, soft, acid base concept. So these are the acid base concept are there that involve in the ionic equilibrium. See, ionic equilibrium, if you talk about ionic equilibrium, can you define what is the ionic equilibrium?
Sir, the equilibrium present in an ionic system or ionic reaction.
The equilibrium existing between what? Existing between ionized and unionized. Ion is called ionic equilibrium. Now ionic equilibrium, one thing you keep in mind, what that is, if it's a strong electrolyte, it will go 100% dissociation. So far there is no equilibrium. It should be the electrolyte should be very, very weak, like this one. So it will ionize less reversibly. So it will give CH3 COO minus and it will give H plus. So here if you are writing Ka, acid dissociation constant, it will be that is product of molar concentration of product CH3 COO minus. Here is H plus divided by what will be there? It will be CH3 COOH. This is there. Getting? No.
Sir, explain once again.
What is this? Is the equilibrium existing between what? Ionized. They are the ionized, and this is the unionized. It's called ionic equilibrium. It means this acid is what? Weak acid. Weak acid means this is forward reaction. It going to acetate ion and H plus ion, and then it is, if it is reversing also to forming the acetic acid. Why? Because it gives lesser number of H plus ion. That is why it is weak acid. Now, if you see HCl, so it will absorb, that is irreversible reaction. H plus plus Cl minus. It will be. So this is the different. Here no ion will be equilibrium will exist. It is irreversible. The first one we are going to study, what's the name? The first one, if you see, that is Arrhenius acid base concept. Arrhenius acid base concept. This is the very, very simple. Okay. Very, very simple. What is their first point? You see, Arrhenius acid base concept. What is the first point of this one? Yeah, you can write this concept is based on what principle they are based on? Based on H plus or OH minus ion in water. Here the important point is there, that is water is important point, compulsory. If water is not there, the concept is invalid. What is there? Acid. What is the Arrhenius acid? Arrhenius acid. If you talk about Arrhenius acid, it gives H plus ion in water. H plus ion in water. This is the Arrhenius acid, right? Next one, if you talk about what will be the Arrhenius base, you write here the Arrhenius base. Can you write?
Yes, sir.
Write down here.
कुछ बन नहीं पाएगा कुछ बात बस देखो ना फोन करना ₹4 है तुम्हारे पास दो
Where you are writing, Sarnay?
I don't know, sir, where the problem is sometimes.
Okay. It gives
It actually gives the OH minus ions in the water.
OH minus ion in water. Okay. Now, example. If you are writing is example, suppose I am writing HCl and here you take the H2O. So what it is going to give, Sarnay? This is the H plus ion plus Cl minus ion. You know, H plus ion is unstable in water. So what it is there? If you are writing HCl plus H2O, so it will give what? H3O plus Cl minus. Another, suppose you are writing H2SO4. Similarly, you write H2O here, so it will give 2H plus SO4, 2 minus. If you are writing HNO3, so what it is going to give? That is, it should be the water is required. This is the H plus nitrate ion. If suppose it is CH3COOH, it will ionize reversibly because it is weak acid. So it will give CH3COO minus plus H plus. So all are Arrhenius acid because they give H plus ion in water. They gives what? H plus ion in water. So they are what? Arrhenius acid. Getting?
Yes, sir.
Okay, now we are going for the next one. Example of Arrhenius base. Example of Arrhenius base. Can you tell me what are example of Arrhenius base?
Sir, NaSO4, MgSO4, NaOH, KOH.
NH4OH. That is correctly you are saying.
Sir, I
Reversibly,
told,
it is.
sir, I told NaOH, sir. NaOH, KOH, MgOH.
Yeah.
Mg.
NaOH. So what it is going to be? Na plus OH minus. If you are writing KOH, so it is going to be K plus OH minus. What you are saying, one other is MgOH whole twice you are saying. That is also the stronger acid will be ionized irreversible. See the single arrow is there. But if it is weak base, so it will be reversible. So this is reaction between Arrhenius acid and Arrhenius base. This is very simple. We study this one. Arrhenius acid and Arrhenius base. Arrhenius base. So it is going to be salt and water. Salt and water. So suppose you are taking the HCl and this is the NaOH. So it will give the salt and water, that is very simple, NaCl plus it is going to be H2O. So it is very simple that we study in the 10th standard. Now the next one, Bronsted acid base concept. Bronsted acid base concept. Can you tell me what is the Bronsted acid base concept? Yes or no? Acid. Here the water H2O not required. H2O not required. In this case, H2O not required. And OH also not required. Also not required. This is the concept where little bit upper level is there. What is acid? Which acid we are talking about? Bronsted. This is going to be Bronsted acid. What is Bronsted acid? It gives H plus ion. It gives H plus ion, that much only. Bronsted base, Bronsted base, Bronsted base. It takes H plus ion. It takes H plus ion. So if anything is giving H plus ion, that is acid. If taking H plus ion, that is base. Okay. Now, suppose if I will talk about HCl, HCl. So what it is going to be, it is giving H plus ion and plus Cl minus. So it can be Bronsted base also because it is giving H plus ion, Bronsted base. Okay, Bronsted base. And if anything is taking the H plus ion, suppose if I will write OH minus ion and it is taking H plus. So it is forming H2O. So since it take H plus ion, so it is going to be what? Sorry, the first one is Bronsted acid. It gives H plus ion, na? Bronsted acid. Which one? This one, HCl. And this
Yes,
is the
sir.
Bronsted base. OH minus ion is Bronsted base. Why it is Bronsted base? Because it takes H plus ion. Getting? No. Are you getting or not?
We're not audible. So once again, repeat sir, what you just told.
Your sound itself is not coming. You are not in the reachable. You be
No,
little
sir.
bit.
The sound is coming, sir. Probably what is happening is that the network is slow. That is why sound is not going. Probably, so that might be the problem.
So Bronsted acid means what? That gives what? H plus ion. And Bronsted base means what? That takes H plus ion. This is.
It's plus or gives OH minus.
Yeah. OH minus it is not going to. Taking. See, it takes H plus ion. Bronsted base takes H plus ion. Bronsted acid gives H plus ion. No OH ion required. No OH minus ion not required. That it should give OH minus ion, then it will be base. That is not concept. Getting? Now, next one. Conjugate acid base conjugate acid base pair. Acid base pair. Conjugate acid base pair. Okay. What do you mean by conjugate acid base pair? Acid have conjugate base. Acid have conjugate base. Okay. And next one. Base have conjugate acid. Base have conjugate acid. Okay. Next, this is what the point. Next one. Conjugate acid base pair, is differ by only what is differ by? Differ by H plus ion only. H plus ion only. Okay.
Yes.
Now see. NH3 is there. If I will write NH3 plus H2O. This is there. It is going to give NH4 plus and OH minus. Now see. What is there? If I will consider this one conjugate, this is the base. This is the base. And water is acting as a acid. So base is having what? Conjugate acid. This is what? Conjugate acid. Conjugate acid. Base have conjugate acid. So if the base is there and if you are adding H plus ion, so it is going to give what? Conjugate acid. This is the conjugate acid. Now another thing, if acid is there, if we are having acid and minus H plus ion, so it is going to give conjugate what? Base. Now you see what is happening. Here I have considered this water molecule as a acid. It losing H plus ion. So what it become? It become the conjugate base. Yes or no? Not able to understand this one? Hello?
Yes, sir. Sir, in
Getting or not?
H3, sir, sometimes getting disconnected actually, sir. Up to here, we have the base between H
Uh-huh.
plus acid H plus the
Yeah,
conjugate
I
acid.
can understand. I can understand. Let us see one more example. What example I am giving?
Sir, you hold
This.
1 minute, sir. You write down whatever it.
Okay, you want to write. Okay, write down.
So the slide went away, but
What?
so the slide now, sir, it just went away. That's what.
This is there, Sanoy. Everything.
Sir, okay.
Done.
Yes, sir.
Okay. So now I am giving you one more example. Suppose I am having CH3COOH and I am putting this one in water. So this side, this is the acid. If it become the acid, and then it is what is base. Okay. Now, acid is having what, Sanoy? Acid is what is having acid? Acid have conjugate base. So what it is going to be? CH3COO minus. This become conjugate base. Conjugate base. It do not have the H plus. And then it become H3O plus. So it become conjugate acid. This is the conjugate acid. Now see. Acid have conjugate base. Acid have conjugate base. This one. And base have what? Conjugate acid. This one.
So that means whatever that is, its opposite one is having.
Opposite one, but we have to understand now.
Hmm.
Acid is there na. Acid lost H plus ion. So it becomes
Yes.
Cb, conjugate base. Right?
Mhm.
Base is there. It gain H plus ion. It become conjugate acid. See the front, this one. Base plus H plus, conjugate acid. Acid minus H plus, conjugate base. Concept must be clear. Is it okay?
Yes, sir.
Now go for the next one. I am giving you the species. Here species are there. And you need to write the conjugate acid. Conjugate acid. You need to write. And here is what is there? Conjugate base. Conjugate base. What are the species are there? NH3. C2H5OH. Next one, HSO4 minus. HS minus. HCO3 minus. H2O. We are having if you find the NCERT book, in the NCERT book also some problem will be there. I don't have here NCERT book. Okay, solve it now. What the concept you need to use here? What the concept you are going to apply? That acid is there. Acid loss H plus ion. It become conjugate base. Base is there. Gain H plus ion. Conjugate acid. So NH3 is there. If you want to write the conjugate acid, so it should gain H plus or the loss H plus. Conjugate acid means it should be added with the H plus. Yes or no? Hello. So it
Yes,
will
sir.
be NH4 plus. And it is losing, that is NH2 minus. This is the what is going to be conjugate base. This is the first one.
Yes, sir.
Next one, C2H5OH. So C2H5OH2, positive charge. And here is C2H5O minus. This will be the conjugate base. HSO4. So it will convert into H2SO4. And here it lose, that is SO4 2 minus. Next one, HS. So H2S. Here will be S2 minus. H2CO3. Here is CO3 2 minus. H3O plus. OH minus. Can you understand conjugate acid base concept?
Yes, sir.
Hmm?
Yes,
Yes, sir or no, sir?
sir, understood.
Hmm. Can I reach?
Yes. No, no, sir. 1 second, you please. Don't do this.
Can I reach?
No, no, sir. Last column I'm writing. Sir, done.
Okay, very good. So this is what? Now we are going for the next one. Lewis acid base concept. Lewis acid base concept. Okay. What is the Lewis acid base concept, Sanoy? It is based on lone pair electron. Lone pair electron. That is also called electronic concept. This is called electronic concept. And this is very, very important. What is the Lewis acid? If you talk about Lewis acid, what is Lewis acid? Here,
Electron deficient species.
they are saying the species which accept, this is going to be which accept lone pair electron. If it is accepting lone pair electron, okay, lone electron is called, are called, that is anything, are called, what is Lewis acid. Lewis acid. Okay. Now, the example one? What are the example? All positive cation. All positive cation. Like cation is what is there, whatever you are writing, like CH3 plus is there. Okay. H plus is there. They can accept the lone pair electron, whatever you are writing, it should accept the lone pair electron. So that is Lewis acid. Like next one. A species of incomplete octet. A species of incomplete octet. Incomplete octet. Whatever the species are there, if incomplete octet are there, like the BCl3, AlCl3, FeCl3, they are, if you see the Al, Al is what is there? 13, no? 2, 8, 3. Okay, 3 valence electron. Cl you see 17, 2, 8, 7. Now, if you see this one, so Al is there. Al is there here. So what will be there, Sanay? That is 1, 2, 3. This is Cl. Here is Cl. Cl. This is. So if you make the bonding here, sharing of electron, so what you are going to find? How many electrons are there? Can you see? Total electron is 6 electron. So it is incomplete octet, yes or no?
Yes, sir.
So 6 electron means it can accept 2 electron.
No.
Yes or no?
Yes.
So it will be again, it will be the Lewis acid. Okay. Next one, you can be the third one. Atoms with incomplete octet. This is also the example are there. Incomplete octet. These are the example of the Lewis acid. Okay. Now we are going to see the Lewis base. If you see the Lewis base, they are lone pair donor. Whatever the species lone pair donor, whatever species you find, that if they are capable to donate lone pair, that will be the basic in nature. They are lone pair donor. Now, if I will write NH3, although it is having the hydrogen, but it is not the acid. Why? Because it contains the lone pair electron. So it is going to be Lewis base. So first example, if you are writing example 1, a species containing what? A species containing lone pair electron. So whatever species are there, if you have consider, if they are having the lone pair electron, that is regarded as Lewis base. Okay. If suppose H2S is there, that is also Lewis base. Okay. Second one, PH3, that is again lone pair electrons are there. So that is again Lewis base. Okay. Now, next one, all example type 2. What they are saying? All negative charge species are Lewis base. Like if I will write the example like Cl minus, Br minus, H minus, whatever the negative charge are there, OH minus, they are going to regard it as Lewis base. Getting this one? No. Yes. Hello.
Sir, am I audible? Sir, am I audible? Can you hear me?
Yes,
Hello?
audible only.
Negative charge. So I'm writing what you've just written over there in Blackboard. So I'll let you know once it is done. Sir, this one, what you said, this one?
Which one?
This one?
All negative charge.
Oh, so done.
Okay. What will be the reaction between product will form between the Lewis acid and Lewis base?
So product will be so product means I did not understand clearly, sir, what you wanted to say.
That is what? See, like the Arrhenius acid base you treated na, so what it give? That is salt plus water. Conjugate acid base you are treating, what it will give? Means Bronsted acid base, it will give conjugate acid base. Here the reaction between reaction between what is the Lewis acid and Lewis base. Lewis acid and Lewis base. This is reaction between Lewis acid and Lewis base. So what will be there, Sanoy? Reaction between Lewis acid and Lewis base. So it form coordinate bond. It form coordinate bond. Coordinate bond. And species form is coordination compound, or you can say coordinate compound. Next year you have to study one chapter coordination compound. Like you see NH3 is there, NH3. Here is lone pair electron is there. So I am writing in the different form. Let me write in the different way. See, I am writing BH3. Okay, BH3. And here is I am writing NH3. What is here? Lone pair electron is there. It will donate like that. Okay. So the bond is going to form. Here is the hydrogen. This is hydrogen. Here is hydrogen. This will be like that nitrogen. This is the hydrogen, and this is the hydrogen. Okay. Now you see here. See, boron is having what? 5. Boron is 5. 2, 3. So here if you are writing 1, 2, 3. And hydrogen are there. So number of valence electron you can see. Total valence electron is 6. Yes or no?
Yes.
So if it is 6 electrons, so it is going to be what? Lewis acid? Yes or no?
Yes.
Now, if you see the NH3, here lone pair electron is there. Total electron is 5. Nitrogen, if you see, 7. So 2, 5. And here is hydrogen. So this is there. Here. This is also. So now you see what is happening. It is having the octet. There is no problem in this one. But here it is incomplete octet. Lewis base lone pair. So this electron has to be transferred here. Are you getting this?
No, sir.
No, sir. Coordinate bond, how can you say you don't know? Any species is there that has to be completed octet, yes or no?
Yes, sir.
So you see this will be like that. Here. So this lone pair electron belongs to the NH3 only. So if anything is donating the lone pair electron, so what will be there? Here is hydrogen. This is hydrogen. This is nitrogen, hydrogen, hydrogen, hydrogen. This is the coordinate bond. This is coordinate bond. So when Lewis acid and Lewis base react, that is going to form the coordinate bond. Getting?
Yes, sir.
So this is our required answer, Sanoy. So you send the topic's name. Let me check some more topic. Gibbs free energy, ionic equilibrium, Arrhenius, Bronsted, Lewis acid base, ionization constant, common ion effect. Okay. These are the topic. Next one is the, we will be discussing Gibbs free energy in the next class. Okay. Gibbs free energy, we will do in the next class.
Yes.
Total, we will do the Gibbs free energy. Already in the Gibbs free energy, already we have done there in the thermodynamics, but here also we will do the in term of equilibrium constant, right? What is their Gibbs free energy? Delta G is equal to minus 2.303 RT log Kc. So on the basis of this, we will solve the problem and we will discuss about the some other whatever the possibilities will be there. Minus 2.303 RT log QC. This we will discuss in the next class, right?
Yeah.
Okay. Okay.